in this video we're going to verify some trig identities by using these 5 identities right here: reciprocal, quotient, even odd, cofunction identities, and Pythagorean identities. So let's start by looking at some examples and simplifying them and verifying that the left side will equal to the right side. The first one I'm going to start off with is tan of x times cotan of x is equal to 1. I'm going to draw a line right here at the equal sign. Now we have to work with the left side and make sure it ends up equaling to the right side. The right side will always remain 1, but the left side we're going to work with it and we're going to show that it equals to 1. There are 2 ways of solving this question. The first way is by using the quotient identities right here, right? So tan is equal to sine over cosine, and cotan is cosine over sine. So for tan, we'll write sine x divided by cosine of x, and for cotan, we'll write cosine of x over sine of x equal 1. What we did here was we used quotient identities, so we write quotient identity, quotient identity. That's for both of them, for the tan x equals to sine x over cosine x, and for cotan x equals to cosine x over sine x. They're both quotient identities. For the next step, we're going to simplify, and notice how sine x and sine x cancel. You can only cancel when there's a multiplication sign in the middle, not when you're adding or subtracting. And for the for the cosine, we can cancel the cosines. So on the left side, we're left with just 1, because everything simplifies, equals to 1. And because we've simplified, we can just write simplifying here. And that's it for the first method of solving this one. Let's look at the second way of solving this. So we have tan of x equals, that's not true, it's not equals, it's times cosine of x is equal to 1. Again, we'll draw a small line right here. Now if you look at the identities again, instead of using the quotient identity, we're going to use the reciprocal identities. So we're going to switch tan into 1 over cotan, or we can switch cotan into 1 over tan. So let's do that. I'm going to switch cotan. This is not correct. This is tan, cotan. So we have tan. We're going to keep tan the same. Tan of x times cotan is now 1 over tan equals to 1. And because it's 1 over tan, what we did here was to go from cotan x to 1 over tan x, we used reciprocal identity. So we write reciprocal identity. And here we can simplify. Tan x and tan x simplify. Again, we're left with just 1 on top. So 1 equals to 1, and that's by simplifying. So I write simplifying. And that's it. That's the second method. Question number 1, second method. Let's look at a question. Another question. We have 1 plus sine theta times 1 minus sine theta. Not sure what happened there. So 1 minus sine theta is equal to cosine squared theta. Now, notice how the right side, the answer is in terms of cosine only, and on our left side we have 2 sines. We're going to try to get this in terms of cosine. So what we're going to do is we're going to start by expanding or by foiling. So we're going to do 1 times 1, which is equal to 1. Change the color, so it's 1. 1 times negative sine theta is negative sine theta, so negative sine theta. Sine theta times 1 is sine theta, so plus sine theta. And then sine theta times negative sine theta is negative sine squared theta. So write negative sine squared theta equals to cosine squared theta. Right here we just expanded, and this one would be properties of algebra. So we write property of algebra. Next, negative sine theta and sine theta, negative sine theta plus sine theta, they're opposite signs, so they cancel each other. That's simplifying, so we write 1 minus sine squared theta on the left equals to cosine squared theta on the right. And what we just did here was we simplified, so we write simplifying. Now, on the left side here, we have 1 minus sine squared theta. If we look on top at the Pythagorean identity, the one we're going to use right here is sine squared theta plus cosine squared theta equals to 1. So let's write that down. I'm going to start by writing sine squared theta plus cosine squared theta is equal to 1. If we subtract sine squared theta on both sides, subtract sine squared theta here, subtract sine squared theta on the right side, these cancel. We're left with cosine squared theta on the left equals to 1 minus sine squared theta on the right. So this becomes cosine squared theta, and this is exactly the same thing. So for the left side here, we write cosine squared theta is equal to cosine squared theta, and we've verified this identity by using Pythagorean identity. So we write Pythagorean identity. And that's it for this question. Let's look at one more. Question number 3. We have cosine squared theta, or cosine squared x, let's use x for this one, minus sine squared x is equal to 2 cosine squared x minus 1. Again, if we look at the right side, we notice how the right side is in terms of cosine only. So we need to change the sine squared in terms of cosine squared. And for this one, we're going to use Pythagorean identity. Again, I'll write the Pythagorean identity for this one on the right side, which is sine squared x plus cosine squared x is equal to 1. So if we subtract cosine squared on both sides, these cancel. We're left with sine squared x equals to 1 minus cosine squared x. And here we're going to substitute 1 minus cosine squared in for sine squared x here. So we end up with cosine squared x minus sine squared, which is now 1 minus cosine squared x. Make sure that you put the parentheses because the negative will distribute in and change the signs inside. And that's equal to 2 cosine squared x minus 1. Here we use the Pythagorean identity. So let's get rid of this here and write Pythagorean identity for this step right here. Pythagorean identity. Now we're going to expand the negative in here. Negative 1 times 1 and negative 1 times negative cosine squared x. So we have cosine squared x minus 1 minus negative cosine, so plus cosine squared x is equal to 2 cosine squared x minus 1. Here we just expanded, so this is a property of algebra. That's a weird looking G. Now we simplify. Cosine squared plus cosine squared is 2 cosine squared. So we have 2 cosine squared x minus 1 is equal to 2 cosine squared x minus 1, and we just verified the identity by simplifying. All right, let's look at a fourth example. Example number 4, we have tan of pi over 2 minus theta times tan theta is equal to 1. So for this question, we're going to have to use the cofunction identity, since we have tan of pi over 2 minus theta, which is right over here. And this is equal to cotan of theta, so this becomes cotan of theta times tan of theta is equal to 1. Again, we're going to leave the 1 exactly the same on the right side. And we're going to work with the left side. And here, let me just move this to the side so we can write the identity that we're using. For this first step, the first identity is cofunction identity. And then here for this one, we can use either the reciprocal identity or the quotient identity. Let me use the quotient identity for this one. So I'll write cotan as cosine of theta over sine of theta times tan is sine theta divided by cosine theta equals to 1. Here we used quotient identities. So let's write down quotient identity. and then we can simplify. Seeing that we're multiplying, we can simplify top and bottom, or we can simplify across from each other, so these two. Cosine and cosine cancel. Sine and sine cancel, so we're left with just 1 on the left side. We have 1 is equal to 1. And here we simplified, so we can just write simplifying. And we've finished this verification question. Let's just do a couple more. That one was question 4. Let's do question 5. Let's do secant squared y minus cotan squared pi over 2 minus y is equal to 1. Let's draw a line right here. And we're going to make this guy a little smaller. Again, we want to fit everything in. Move to the side. Again, we're going to use a cofunction identity here because we have a pi over 2 minus y over on this side. So let's move this to the side a little bit more. And we start by writing secant squared y minus cotan of pi over 2 minus y is equal to tan of y. If you notice this one right here, cotan of pi over 2 minus theta is equal to tan of theta. So for this one, instead of cotan squared, we're going to write tan squared of theta equals to 1. What we did here was we used cofunction identity, so we'd write cofunction identity. Now for the next step, for this next step, we're going to use Pythagorean identity because we can switch either, we can change either sine squared, secant squared, whoop, something got erased here. We can either write secant squared in terms of tan squared plus 1, or we can write tan squared in terms of secant squared minus 1. Let's just go the easy way and write secant squared as tan squared x plus 1. So this becomes tan squared y plus 1 minus tan squared y, which is right over here. So tan squared y, not theta, let me erase that theta here. Y equals to 1. And here we use Pythagorean identity, so we got to write Pythagorean identity. Pythagorean identity. And now on the left side, you notice how tan squared y minus tan squared y, they cancel each other out, and we end up with 1 is equal to 1. Here, this is simplifying. And this has been verified. That's question number 5. All right, guys, let's do number 6, question number 6. For question number 6, we have 1 over tan of x plus 1 over cotan of x is equal to tan of x plus cotan of x. For this one, we're going to use the reciprocal identities. Reciprocal identities are right over here. So what we're going to do is we're going to move this equation to the left, so we have a little bit more space to work with. Let's draw a line right down the middle right here. That's not very straight. Let's do it again. There we go. So now we're going to work with the left side and show that it equals to the right side. So hence we're verifying that the left equals to the right. 1 over tan is equal to cotan. You can see that right over here. 1 over tan is equal to cotan. So for the first fraction right here, 1 over tan x is equal to cotan x plus 1 over cotan x is equal to tan x. For both of these, I use the reciprocal identity. So I'm going to write equals tan of x plus cotan of x, and that's reciprocal identity. And if you notice, we have cotan x here is equal to cotan x here, and tan x here equals to tan x here. So we're done. This equation has been done. And that's it for number 6. Let's look at number 7. All right, for number 7, we're going to do 1 plus sine theta over cosine theta plus cosine theta over 1 plus sine theta. And that should equal to 2 secant theta. Let's draw a line right down the middle. Let's extend this line a little bit. And let's move it to the left a little bit so we have some space. Okay, now in this case, in order to add two fractions that are not the same and they don't have the same denominator, we'll have to find the same denominator. So let me write it in a way where I can have some space to write a common denominator. There, so for this question, we're going to do 1 plus sine theta divided by cosine theta. Leave a bit of space, plus cosine theta over 1 plus sine theta is equal to 2 secant theta on the right side. A little bit more space. So for this one, to find a common denominator, the common denominator in this case would be cosine theta times 1 plus sine theta. So for the left, we're going to multiply by 1 plus sine theta on the left and cosine theta on the right side. So on the left, we'll multiply by 1 plus sine theta, top and bottom. Let's zoom in a little bit. 1 plus sine theta. And on the right, we're going to multiply by cosine theta. Now we have a common denominator, so we're going to expand the top. 1 times 1 is 1, plus 1 times sine theta is sine theta, plus another sine theta, plus sine theta times sine theta is sine squared theta, plus cosine times cosine is cosine squared theta. And all that is now over the same denominator, which you can write once, which is cosine theta times 1 plus sine theta. That's equal to 2 secant theta. By the way, from the step before, from here to here, we did properties of algebra. And we also expanded, so you write property. That's properties of algebra right here. Properties of algebra by finding the common denominator. And here we multiplied and expanded, so you can write properties of algebra one more time. And we're going to simplify. So now we're going to write sine theta plus sine theta is 2 sine theta. So we have 1 plus 2 sine theta plus. So we're simplifying this part, but for this part here on the right side, this part right here, that's equal to 1. Since sine squared theta plus cosine squared theta equals to 1. That's the Pythagorean identity. But we'll do it on the next step because some teachers want each step to be written separately. So we keep it as sine squared theta plus cosine squared theta. And that's still equal to 2 secant theta all over cosine theta times 1 plus sine theta. Here what we did was we simplified by writing sine theta plus sine theta is equal to 2 sine theta. So we write simplifying. Now the next step is to notice that sine squared plus cosine squared is equal to 1. That's using the Pythagorean identity. So we write 1 plus 2 sine theta plus 1 all over cosine theta times 1 plus sine theta. And that should equal to 2 secant theta. Here we use Pythagorean identity, so we write Pythagorean identity. And the next step, notice how 1 plus 1 simplifies to 2. So we write 2 plus 2 sine theta all over cosine theta times 1 plus sine theta is equal to 2 secant theta. Here we used 1 plus 1 equals to 2, so here we simplified. So write simplifying. Now we're going to factor out the 2 on top. 2 plus 2 sine theta, they both have 2 in common. So I'm going to factor out the 2. We have 2 times 1 plus sine theta divided by cosine theta times 1 plus sine theta, and that is equal to 2 secant theta. Again, on the right side we have 2 secant theta. Here we factored out, so it's again properties of algebra. And since we have 1 plus sine theta on the top and 1 plus sine theta on the bottom, so the numerator and the denominator, they cancel. And we're left with 2 over cosine theta is equal to 2 secant theta. And remember that 1 over cosine from the reciprocal identities, 1 over cosine is secant. So this becomes 2 times secant theta is equal to 2 secant theta, which is what we're trying to verify. And here we use the reciprocal identity, so we write reciprocal identity, and we're done with this question. Here we're going to write simplifying, because we simplified by canceling out 1 plus sine theta on top and bottom. And that's it for this question. Okay, next question is number 8. So let's do number 8 here. For number 8, we have cosine theta times cotan theta all over 1 minus sine theta minus 1 is equal to cosecant theta. Let's draw a line right here. We're not going to touch the right side. We're going to keep the right side the same, but we're going to work with the left side. So first thing I'm going to do is I'm going to write cosine as is. I'm going to rewrite the cosine as is. But then for cotan, I'm going to write it as cosine theta divided by sine theta equals to cosecant theta. We just wrote cotan theta in terms of cosine and sine. And we're going to try to find something that we can simplify top and bottom. But before we do that, let's simplify the top. Cosine theta times cosine theta over sine theta. This one here is over 1. And let's not forget what we used. We used the quotient identity. So let's write that down. Quotient identity for this first step. Now for the second step, cosine times cosine is just cosine squared. So write cosine squared theta over sine theta all over 1 minus sine theta is equal to cosecant theta. Here what we did was we just simplified. Cosine theta times cosine theta is cosine squared theta, so we simplified it. We write simplifying. Extend this line. And we go back to this question right here. So cosine squared, I see I have a 1 minus sine squared on the bottom. And in order to get this, because the answer on the right side is just cosecant, which is 1 over sine. Even though we have a sine on the bottom here, we have 1 minus sine, which is not the same thing. And I want to get rid of this here. The only way I can get rid of it is if I use cosine squared, if I write cosine squared in terms of sine squared by using the Pythagorean identity. So if we recall, I'm going to write it in blue. If we recall, sine squared x plus cosine squared x is equal to 1. And cosine squared x is equal to 1 minus sine squared x. So I'm going to simplify. I'm going to write down 1 minus sine squared x in for cosine squared x here. All right, 1 minus sine squared x all over sine of theta, or sine of x. Let's write down theta instead of x here. That's equal to cosecant theta. And forgot the 1 minus sine on the bottom, 1 minus sine theta here. That's equal to cosecant theta. And what we did here was we used Pythagorean identity. So let's write down Pythagorean identity for this one. Now, I want to get rid of this one, but in order to do that, I'd have to write 1 minus sine squared as 1 plus sine times 1 minus sine, which is difference of squares. So for this one, we're going to write a squared minus b squared is equal to a plus b times a minus b. That's difference of squares. So this on top becomes 1 plus sine theta times 1 minus sine theta all over sine theta. That's only for this part right here. That's for this here, for the top. But then for the bottom, for the 1 minus sine theta, this is 1 minus sine theta over 1. And when you divide by a fraction, you multiply by its reciprocal. So it becomes 1 over 1 minus sine theta. And here in this case, we can simplify by canceling out these two. Before we do that, let's write down what it equals. It's equal to cosecant theta. And what we did here was we used the difference of squares, which is algebra. So we write properties of algebra. And now we're going to simplify. 1 minus sine theta and 1 minus sine theta, they cancel out. So we end up with 1 plus sine theta over sine theta. So we're going to write cotan theta in terms of sine and cosine by using the quotient identity. And if we recall that cotan theta is equal to cosine theta divided by sine theta. And that's a quotient identity. So we write on the left, we write cosine of theta times, it's not working, times cotan, which is now cosine theta over sine theta, all over 1 minus sine theta minus 1 is equal to cosecant theta. Here we use a quotient identity, so we write quotient identity. Now on the top we multiply. We have cosine theta over 1 times cosine theta over sine theta. And this simplifies to cosine squared theta over sine theta all over 1 minus sine theta minus 1 equals to cosecant theta. Here we just simplified by multiplying cosine by cosine, which is simplified, so we write simplifying. Now for the next step, notice how cosine squared on top here, because the only way that we can simplify this into cosecant theta on the right side is 1 over sine theta. Here we have a sine theta, but we also have a 1 minus in front of it. So we can't just simplify by getting rid of this. What we have to do is we have to find something where, let me just fix this, sine theta, where cosine squared theta ends up being sine squared theta, which is going to be using the Pythagorean identity. So if we recall Pythagorean identity, let me write it on top here. The Pythagorean identity is sine squared plus cosine squared theta is equal to 1. What I'm going to do is I'm going to subtract sine squared on both sides of the equation. We end up with cosine squared theta equals to 1 minus sine squared theta. So here for cosine squared, I'm going to write 1 minus sine squared. So we write 1 minus sine squared theta all over sine theta, and this all of this over 1 minus sine theta minus 1 equals to cosecant of theta. Here what we did was we used the Pythagorean identity from cosine squared to 1 minus sine squared. That's the Pythagorean identity. So I write Pythagorean identity here. And now in order to simplify, this one and this one cannot be simplified or cancelled with each other because there's a squared here. There's a small 2 on the top here, which signifies this is squared. So we can't simplify. So what we're going to do, first let's fix the 2. What we're going to do here is we're going to use difference of squares. Now remember that a squared minus b squared is a plus b times a minus b. And this is a difference of squares. So this becomes 1 plus sine theta times 1 minus sine theta all over sine theta, that's for the top, divided by, all of this divided by 1 minus sine theta. So put 1 minus sine theta minus 1 is equal to cosecant of theta. And here we factor this into these two, and we write properties of algebra. So that's properties of algebra. Now let's simplify further. So we have 1 plus sine theta times 1 minus sine theta all over sine theta. And this is still over 1 minus sine theta over 1, but when you divide by a fraction, you multiply by its reciprocal. So it becomes 1 over 1 minus sine theta. And we don't forget to write the equals on the right side. Let's extend this a little bit. And on the right side, this is equal to cosecant theta. Yep, it's cosecant theta. In this case here on the left, if you look on the left, by the way, this one we used by flipping this and writing it as a reciprocal. Again, we've simplified here, or properties of algebra rather. Let's write properties of algebra. And the next step would be to cancel. Because we have a multiplication, we can cancel top and bottom, or we can cancel side to side. But we can't cancel on the top or on the bottom together. Here we have 1 minus sine theta and 1 minus sine theta. These ones cancel out. Where's the minus 1? There's a minus 1 here that I forgot to put here. Let's do that. So there's a minus 1 here. This simplifies to 1 plus sine theta over sine theta minus 1 equals to cosecant theta. And here what we did was we simplified. So you write simplifying. And the next step is I'm going to split this into two different fractions by writing 1 over sine theta plus sine theta over sine theta minus 1 equals to cosecant theta. Again, here we use properties of algebra by splitting a fraction into two. That's properties of algebra. And this one, the 1 over sine theta, I'm going to write it as 1 over sine theta for now. Keep it the same. Plus sine theta divided by sine theta is just equal to 1. And then minus 1 equals to cosecant theta. And here we've simplified. That's simplification. Let's extend this a little bit. Okay, and now here the ones cancel, so these two cancel with each other because 1 minus 1 is 0. So we have 1 over sine theta on the left equals to cosecant theta on the right, and that's again simplifying. And finally, the last step is to notice that 1 over sine theta is just cosecant theta by using the reciprocal identities. So we have cosecant theta is equal to cosecant theta by using reciprocal identity. So right, reciprocal identity, and this question is done. All right, guys, question number 9. Let's do 1 over cosine x plus 1 plus 1 over cosine x minus 1 is equal to 2 negative 2 cosecant, let's write it a bit bigger, cosecant x cotan x. Okay, so let's first move it to the left so we can write down what the identities are. And let's put a line right through the middle, right over here. Okay, so let's look at this again. So in this case, again, we can't simplify left and right because there's a plus sign here. The only thing we can do is find a common denominator. So let me make a little bit of space again and shift this one to the right. Let's keep this one the same. And we start by writing 1 over cosine of x plus 1. I'm going to keep a bit of space. Plus 1 over cosine of x minus 1. Now I'm going to multiply by cosine x minus 1 here, top and bottom. I'm going to multiply by cosine x plus 1 here, top and bottom, to get the common denominator. So let's do that. So I multiply here, top and bottom, by cosine x minus 1, and here cosine of x minus 1. That's for the left part of the equation, and for the right side, it's cosine of x plus 1 and cosine of x plus 1. And that's still equal to negative 2 cosecant x cotan of x. So here on the left side, I have cosine of x minus 1. That's for the numerator. Plus, that's the plus here. And then we have 1 times cosine x plus 1. So I write cosine x plus 1 all over cosine of x plus 1 times cosine of x minus 1. Again, for the first part, forgot to write what that is. By adding a common denominator, I just did properties of algebra. And then here we simplified by adding the top and writing them both on top here. So this is simplifying. Let's just copy paste this to make it easier. And here we just did properties of algebra, or simplifying rather. And now on the top here in the numerator, we have cosine x plus cosine x. That's 2 cosine x. And then negative 1 plus 1, they cancel. So we're left with 2 cosine x on the top in the numerator over cosine x plus 1 times cosine x minus 1. And that's equal to negative 2 cosecant x cotan x. In this case, we have cosine squared x plus 1 and cosine x minus 1. If we multiply this out, we end up with 2 cosine x on the top. And on the bottom, since this is a plus b and this is a minus b, they simplify into a squared minus b squared. So for the denominator, we have cosine squared x minus 1 squared, which is 1. That's equal to negative 2 cosecant x cotan of x. And if we look at the Pythagorean identity, which is, let's write this down here. So we have sine squared x plus cosine squared x is equal to 1. So on the left side, we have cosine squared x. If we move the 1 to this side and move the sine squared to the other side, we end up with cosine squared x minus 1 equals to negative sine squared x. So cosine squared x minus 1 is actually equal to negative sine squared x. So let's write that down. The next step, let's add a new page. So the left side becomes 2 cosine of x divided by cosine squared x minus 1, which is now negative sine squared x. And that's equal to negative 2 cosecant x cotan of x. Let's draw a line in the middle here. Let's go back to this. So we have 2 cosine x over negative sine squared x, and we have to show that this is equal to the left side, to the right side. So what we do here is we're going to separate them into 2 cosine of x divided by negative sine squared x is sine x times sine x. I'm going to put this in the denominator here, and I can put over 1 on the top. Because 2 cosine x times 1 is 2 cosine x, that doesn't change anything. And sine x times sine x is sine squared x. So again, that doesn't change anything. So here we just did properties of algebra. Negative 2 cosecant x cotan of x. Here it's properties of algebra. For the previous step, we used Pythagorean identity to get from here to here. So just write Pythagorean identity for this first step here, Pythagorean identity. And now we can write negative 2 cosine x divided by sine x is cotan x, which is what we have on the right side, and 1 over sine is cosecant, which we also have on the right side. But like I said before, some teachers want you to do each one by itself, so 2 steps here. Let's do the cosine x over sine x first. That gives us cotan of x times 1 over sine of x is equal to negative 2 cosecant x cotan of x. And here what we did was we wrote cosine x over sine x in terms of cotangent x. That's using the quotient identity. So we write quotient identity for this step. And the next step is when we write 1 over sine x in terms of cosecant x by using reciprocal identity. And that's what we're going to do right now. So it's negative 2 cotan x times 1 over sine, which is cosecant of x, is equal to negative 2 cosecant of x cotan of x. And this is using reciprocal identity. So write reciprocal identity. And we've verified that the left equals to the right. And that's it for this one. Okay guys, for question number 10, we're going to do an easy one for this one, which is secant y times cosine of y is equal to 1. And notice how secant of y is 1 over cosine of y. So we're going to use this one. First, let's draw the line in the middle. And we're going to work with the left side and show that it's equal to the right side. So for secant of y, why did it erase? Don't want it to erase. For the secant of y, I'm going to use secant is 1 over cosine. So we write secant of y is 1 over cosine of y times cosine of y is equal to 1. Here we use a reciprocal identity, which is on the right side. So we write reciprocal identity. And then on the left, notice how cosine y and cosine y cancel each other out. So we're left with 1 equals to 1, and that's simplifying. So we write simplifying on the right side. And we're done. We just simplified it, and that's it. Let's look at number 11. So number 11, we have tan squared of theta over secant of theta is equal to sine theta times tan theta. For this one, if you notice on the left there's tan squared, on the right there's tan. So we're going to split this one into two. The tan squared, we're going to split it into two so that we can keep one tan on the left that matches this one, and then on a different tan ratio we're going to work with and get it to equal to sine. So the best thing to do here is to write tan squared as, let's draw the line first, keep forgetting that line. So we go back to this, we have tan squared, which I'm going to write as tan theta times tan theta times 1 over secant theta. I just rewrote it as tan squared is equal to tan times tan, and the secant on the bottom, I just wrote it as 1 over secant theta. That should equal to sine theta tan theta. Okay, now we're gonna, this one here, the tan theta here and the tan theta here, we're not gonna touch them because they already match each other. We just have to show that this part here is equal to this part right here. So tan theta over secant theta is equal to sine theta. Let's use that. And now we're gonna do tan theta, which is this one that we're gonna keep the same. And the second tan theta, we're gonna write it as sine theta over cosine theta times 1 over secant. And here we converted from tan into sine over cosine, and that's using the quotient identity. So we write equals to sine theta times tan theta using quotient identity. Now, the next step here is to notice that there's a sign here and there's a sign here as well. So we want to keep this sign. That means that the tan and the sine here are equal to tan and sine here. And these two have to cancel each other out, which they will, by writing 1 over secant as cosine, because that's the reciprocal identity. So the next thing we're going to do is we're going to write tan theta times sine theta over cosine theta times 1 over secant, which is now cosine theta, is equal to sine theta times tan theta. And here what we did was we wrote 1 over secant as cosine, and that's reciprocal identity, which is reciprocal identity. Now the second to last step is to show that this one and this one cancel out, and that ends up being tan theta times sine theta is equal to sine theta times tan theta on the right side. And we've proven that the left equals to the right. We've verified the identity, and here we did this by simplifying these two. So we write simplifying. And that's it for this one. Okay, let's look at question number 12. So question number 12 is, let's choose cotan squared x divided by cosecant x is equal to 1 minus sine squared x over sine of x. Okay. Let's draw a line in the middle. And let's look at this one. Let's move this a little bit to the left. Okay, so for this one, we're going to first start by writing cotan squared in terms of sine and cosine. And if we recall that cotan of x is equal to cosine of x divided by sine of x, and that's a quotient identity. So let's start by writing cotan squared as cosine squared x over sine squared x all over cosecant of x equals to 1 minus sine squared x. The x should be on the bottom, not in the numerator. So sine squared of x all over sine of x. Here we use the quotient identity. So let's write down quotient identity here. And from here, we're going to write cosecant x as 1 over sine. So let's do that in the next step. We have cosine squared x over sine squared x divided by 1 over sine x. And that is equal to that's equal to 1 minus sine squared x all over sine x. Here we used reciprocal identity to write cosecant x in terms of 1 over sine x. So we write reciprocal identity. Now, when you divide by a fraction, we multiply by its reciprocal. So for the next step, we're going to write cosine squared x over sine squared x times sine x over 1. That's equal to 1 minus sine squared x over sine x. Here we just did multiplied by the reciprocal, and that's properties of algebra. So write property of algebra. Let's extend this line here. And notice how we have a sine x here and sine squared x here. So we can simplify by getting rid of the sine here and only one of the two signs on the bottom. So that leaves us with cosine squared x over sine x is equal to 1 minus sine squared x all over sine x. Here we simplified, so we write simplifying. And then cosine squared x, using the Pythagorean identity, cosine squared x is just equal to 1 minus sine squared x. So we write 1 minus sine squared x over sine x is equal to 1 minus sine squared x over sine x. And here we use the Pythagorean identity. And that's it. It's been proven. Okay guys, for question number 13, let's do square root of 1 plus sine x over 1 minus sine x is equal to 1 plus sine x over cosine of x with the absolute value. Let's put the line in the middle. All right, now notice how on the left side we have the square root of 1 plus sine x, and on the right side we have just 1 plus sine x. That means that somewhere along the way this would have had to been a squared, so that when you take the square root of something squared, you end up with just 1 plus sine x. In order for this to become a square, we have to multiply it by itself. So that gives us a hint on what we need to do. So let's start by writing 1 plus sine x over 1 minus sine x. And we're going to multiply the top and the bottom by 1 plus sine x to get that 1 plus sine x squared on the top. So we have 1 plus sine x over 1 plus sine x, which is equal to 1. So we can multiply by something that is equal to 1 without changing the whole expression. And that is equal to 1 plus sine x over cosine x, absolute value. This one looks a little bit, I like it to look a little bit more straight, so let's twist it around. Okay, that's not working, so let's forget that. Okay, and now here we have the square root of 1 plus sine x squared all over 1 minus sine x times 1 plus sine x. We're going to multiply the bottom out, but first let's just write down what we did for the top. And here we did 1 plus sine x over cosine of x. Here we just did properties of algebra because we multiplied by a fraction that is equal to 1. Now the bottom, we're going to multiply it out by foiling. So we end up with the square root of 1 plus sine x squared over 1 minus sine x times 1 plus sine x. That is a difference of squares, which is a plus b times a minus b is equal to a squared minus b squared. Right, so the bottom here, so for the bottom, 1 minus sine x times 1 plus sine x is the same thing as a plus b times a minus b. And that becomes 1 minus sine squared x. Let's extend this guy. And that is equal to 1 plus sine x over cosine of x. Here we used foiling and simplifying, which is simplifying or properties of algebra, depending on how your teacher wants you to write it. So it's simplifying. And for the next step, notice how 1 minus sine squared x becomes cosine x. That means that this would have had to been 1 minus sine squared is cosine squared from the Pythagorean identity. So the Pythagorean identity is sine squared of x plus cosine squared of x is equal to 1. And 1 minus sine squared, if we move the sine squared to the other side, we end up with cosine squared x equals 1 minus sine squared x. So for 1 minus sine squared x, which is here, I'm going to substitute that with cosine squared x. Let's get rid of all this. And continue here. So we have 1 plus sine of x squared all over 1 minus sine squared x becomes cosine squared x is equal to 1 plus sine x all over cosine of x, absolute value. And here we use Pythagorean identity to go from this step to this step. So we write Pythagorean identity. And for the final step, we're just going to take the square root. So the square root of 1 plus sine x squared is just 1 plus sine of x divided by the square root of cosine squared is just cosine of x, but we put absolute value because you want it to be positive. And that's equal to 1 plus sine of x all over cosine of x with the absolute value. And that's just simplifying because we took the square root and we write simplifying. And we just verified that the left equals to the right. Thank you guys for watching.